In this lesson we're going to look at the chemical properties of aluminium. First of all, we can say that aluminium is the most abundant metal in the Earth's crust. Okay, something like 8% of the Earth's crust is made from aluminium, and that helps to keep down the cost of obtaining aluminium simply through supply and demand. However, we must remember that aluminium is also relatively high up in the reactivity series, so it's above carbon, which means that we can't use the same reduction techniques as we use, for example, with the metals beneath it, such as zinc through to copper. Okay, so in order to extract aluminium, we've got to use electrolysis, which involves, first of all, melting aluminium oxide and then using a whole lot of electricity to separate the aluminium. So that makes the extraction of aluminium quite expensive. Now, where does aluminium appear in the Earth's crust? Well, one of the more common ores is bauxite, and bauxite contains aluminium oxide. So if you want to find out more about the extraction process, then you can go to the section on electrochemistry, and there's a video on the extraction of aluminium using electrolysis. We're not going to go into that in this lesson. This is just a kind of resume of the chemical properties of aluminium. So although aluminium is quite high up in the reactivity series, when it reacts with oxygen and air, it forms a protective oxide layer which adheres quite strongly to the aluminium lattice. Okay, so it sticks firmly to the aluminium lattice, and this oxide layer renders it unreactive with water. So you would kind of expect it to react with water being this high up, but because of this oxide layer it doesn't. Okay, so it won't react with water, which is good, and that makes aluminium very useful, for example, for storing food or for food packaging and for construction in general. Now, the third thing we're going to mention about aluminium is that it forms an amphoteric oxide. So we're just going to have a look at what that means. So aluminium is in period 3 of the periodic table, and you'll know that the group 1 and the group 2 metals tend to form strong basic oxides, okay? While at the end of the period, the group 7, 6 and 5 oxides will tend to be strongly acidic. Now, silicon oxide tends to be quite inert, but it will react with molten sodium hydroxide. But aluminium oxide, being positioned in between the acidic oxides and the basic oxides, tends to possess both basic and acidic properties. And this is what we mean by an amphoteric oxide, is that it possesses both basic and acidic properties. So it will react with acids, for example, dilute hydrochloric acid. Okay, so you've got aluminium oxide reacting with dilute hydrochloric acid to produce aluminium chloride and water, and it will also react with bases, with alkalis. So aluminium oxide will react with sodium hydroxide to form sodium tetrahydroxoaluminate. So that's a bit of a tongue twister for you. You wouldn't be expected to remember this for your GCSE exams. What you are expected to remember is that aluminium oxide will react with both an acid, and in this case the aluminium oxide is exhibiting basic properties, or it will react with an alkali, in which case the aluminium oxide is exhibiting acidic properties. Okay, now you can see this video on the practical demo section, where balls of aluminium foil are added to a warm solution of sodium hydroxide, and as soon as this protective aluminium oxide layer is removed from the surface of the aluminium foil, then the aluminium is then exposed to react with water, and it does so quite aggressively, rapidly releasing hydrogen gas. Okay, so that's quite an interesting experiment to watch.